Okay, ladies and gentlemen, I decided to make one more video again because of one of your classmates. And I just want to make it clear that when you're factoring polynomials, I've been teaching you one way where basically you just guess and check and just play with the combinations. There's other ways you can factor, okay? If you watch Khan Academy, for example, he does a method based upon grouping, all right? But I think you'll find my method just simpler and easier to use because it's not as intensive when it comes to using numbers and calculating with numbers. Okay? So anyways, so here's some more factoring of polynomials. So as you can see right here, guys, here's problem 13 on a worksheet. Not ours, but another class's worksheet. And let me again show you how I taught it. So here's our problem right here. So let me write it down. We have 4n squared minus 17n plus 4. So instead of doing what I have circled in purple, see if you don't think that this is more straightforward and simpler. Okay? So for example, 4n squared. Normally we would do 2n times 2n, right? But I look right here and I see that 17 and I'm just thinking, you know what? Let me try 4 times 1 first. So I'm actually going to go 4n times 1n. And when I look at the 4 here, guys, notice if I put in 2 times 2, I'm going to get a 2n here, 8 in there. I'm not quite going to get to 17. Right? So let me back up here a little bit. So when I know one set of numbers doesn't work, I just simply try another combination of numbers. So long story short, how do we factor with a 4 at the end? Well, one way is, couldn't we do 1 times 4? And let's see what we get here. I know 1 times n is 1n. 4 times 4 is 16n. Can I get a minus 17 out of this? Sure, as long as both of them are negative, right? So my final answer is 4n minus 1 times n minus 4. And this, notice guys, is exactly what was gotten here. And as you can see, quite a bit less work, right? But again, I mean, if you like factor by grouping, be my guest. But I think just guessing and checking and just playing with the different combinations is the most direct and efficient way of doing these kind of factoring problems. Okay, let's take a look at another example. Here was problem 14, and here I'm going to illustrate. Look what you have to do if you're going to do factor by grouping, guys. Seriously, how many of you guys are going to sit there and try to factor 296? Alright, so if you're not at all familiar with this method that I just obviously circled in green, check out mine, okay? Here's the original problem I want to factor. So I look at this 6x squared and I sit there and go, okay, isn't 6x squared normally 2 times 3x? Now, let's say for some reason 2 and 3 doesn't work. Then hopefully you'll realize I'll actually do 6x times x. See what I did in red there? But I got a feeling that 2 times 3 is going to work. And if you want to know why I know that, is because look at what term's in the middle here, guys. See how small that is? Generally, that's going to clue me into using smaller numbers, right? So I'm going to do 2 times 3 instead of 6 times 1. Now, the last number or constant, again, notice is 49. There's generally only one way to do 49, right? That's 7 times 7. Now let's see what our combinations give us. Notice here I have 21x. Notice 7 times 2 is 14x. Can I take 21 and 14 and make that 7x term in the middle? And the answer is yes. All I need to do is take 21 and minus the 14, right? So I'm just going to do a plus here so that the 7 times the 3 is my 21. and then a minus here will take the negative 7 times 2 and give me my negative 14. And so notice, guys, here is my result. And that, of course, matches what one of your classmates did over here. But again, without all of this extra crazy work here, right? So, again, guys, it's up to you, but I'm obviously biased towards my method. And if you just practice with my method, it works every time. But anyways, let's try one more. So again, look at all of this work here. All right. So again, let me just rewrite the problem here. 6n squared plus 5n minus 6. Okay. And again, see, here's what I'm observing. First of all, I have a 6 in front. I have a small number in the middle again. So I think I'm going to go ahead and try 2 times 3 again. Now, I could be wrong, guys. And if I'm wrong, then I'm again going to try 6 times 1. Now I look at the 6 over here. And normally 6 is again 2 times 3. So how about if I do 2 times 3 like this? And let's see what happens. That's 6. That's 6. Uh-oh, I don't get that 5, do I? Okay, so we'll just back up here a little bit. And hopefully you guys agree 2 times 3 did not work. But what about 3 times 2? Well, isn't 3 times 3 going to give me 9? Isn't 2 times 2 going to give me 4? Can I get a plus 5? Sure. 9 minus 4 is 5, correct? So all I need really, guys, is a plus here, so that 3 times 3 gives me my 9. And all I need is a minus here, so that 2 times 2 gives me the minus 4. And this again is the resulting factorization of that problem. And as you can see, it does match your classmate's answer. So I hope this video helps. Again, I'm not trying to necessarily convince you to use my way, but hopefully you can see how my way is it's actually relying upon how the numbers actually combine together. It's, after all, based on FOIL method. And again, it's up to you. If you prefer doing what I call the X method there and doing grouping, that's fine. More power to you. Okay? But again, please pause the video if you need to. Rewind, watch it. Practice these 3 problems on your own and see if you can't come up with the same results that I did. So until next time, bye.